Question number 74 from AAA module level 1. Find the domain of function root of 16 minus x square. So let's see how to find the domain of this function. So domain means values of x for which function gives output or function exists. Now here they are given f of x is equals to root of 16 minus x square. This will be defined provided the quantity which is inside the square root or under the square root is positive, because square root exists only for the positive numbers. So therefore we would apply condition 16 minus x square should be greater than or equals to 0. So you can make first coefficient of x square positive by multiplying both sides by minus. So when you multiply by minus, inequality is going to get reversed. Factorize it so that you can apply wavy curve method and solve the inequality. So here roots are minus 4 and 4. Mark the roots in number line, then apply the wavy curve method procedure. So extreme right interval will be positive. Here at 4 it is 0. How to judge that? You can put 4 here. 4 minus 4 is 0, so 0. In between this 2 will be minus, because you are crossing the root 4. You have to go and see the factor which gives that root 4. Here power is odd, so it will be minus here. Sign will change. When you come at minus 4, again value will be 0, because at minus 4 this whole thing becomes 0. And when you cross the root minus 4, you can go to that factor, that is x plus 4, which is giving you minus 4. Check power here, power is odd number, so sign has to change after crossing the root. So it becomes plus. So first you should know wavy curve properly to solve any domain problem. Okay, so let us see. Write the final condition or final solution. So x belongs to, they mentioned that inequality here should be less than equals to 0. It means it should be negative. So here x belongs to minus 4 comma 4 should be closed interval, because it can be equals to 0. Next question is question number 75. F of x is log of log x, and they're asking you domain of this function. So for this outer log to be defined, inner quantity must be positive. That's the first condition we'll write here. So mod of log x here should be greater than 0. It cannot be equal to 0. It should be only positive quantity. And another condition will be for inner log to be defined, x, this input, must be positive, otherwise the inner log cannot exist. So both log must be defined, then only function can give the output. So therefore for first outer log we are writing mod of log x should be positive, and for the inner log the input x must be positive, then only inner log can exist. When both of them exist, then only f of x can exist, and that's the definition of domain. Domain means values of x for which f of x exists. Okay, now the first mod, which is written mod of log x, that's always positive as per the log property. So there's only one case it can be 0, that should be excluded, because we know log 1 is 0. Therefore for the first case it is all real number except 0. That's the solution for the first case. And why like this? Because for all real number mod of log x will be positive, but only for one, log 1 value is 0. That cannot be accepted because the mod of log x must be positive, but for log 1 value is 0. Therefore for this case, the first case, the solution is r minus 1, all real number except 1. For the second case, x is greater than 0, so we have to take the intersection of both. So mark in number line. Here we can mark 1. For the first solution, 1 should be excluded, so blank circle, and everywhere else we can mark as a solution. And next case, the solution is greater than 0. Greater than 0, first you can mark 0 toward left, because 0 lies to the left of 1, and that gives you x should be right side of 0. So the common solution is x belongs to 0 comma 1 should be open toward 0 as well as 1 union 1 comma infinity. That's the domain of this function log of log x. Next question is question number 80, where f of x is equal to root of x minus 2 plus root of 1 minus x, and they're asking you domain. Now in this question, because there are two root quantities, both must be defined, then only total function f of x can be defined. Now for the first root to be defined, the quantity x minus 2 must be greater than equals to 0, because inside quantity must be positive, then only root can exist. And the second condition must be 1 minus x should be also greater than equals to 0, then only second root can be defined. So you have to solve them simultaneously now. So you get x greater than equals to 2 and 1 is greater than equals to x. So let us plot the solution and find the intersection of both. So the first case, here you can mark 2 and another point is 1 here for the second case. So first case says x is greater than 2, it means should be right side of 2, including 2 of course. And the second case is x should be less than 1. Less than 1, it means should be left side of 1. So we can notice that there is nothing common between both the region. So whenever and is there, we have to always take intersection. Intersection means common region, and you can notice this side, the second region, that is x greater than 2 and x less than 1. There is nothing common. Therefore, there is no solution. No solution. Or we say another way, domain is phi, null set. Next question is question number 84. F of x is x divided by root of x square minus 3x plus 2, and we need to find the domain. Now f of x exists provided the numerator is defined and the denominator is defined. Numerator is simply x, which is a polynomial, and polynomial is always defined, or the domain is R for the polynomial. Now only trouble can happen is the denominator part, where the square root quantity is there, which is defined provided the quantity under the root is positive. So therefore, to find domain of this function for f of x to exist, x square minus 3x plus 2 must be greater than 0. It cannot be equal to 0 here, because if denominator becomes 0, something divided by 0 becomes not defined. Therefore I have taken here only greater than 0. In rest of the cases we will take greater than equals to 0, because even if it is greater than equals to 0, square root quantity can exist. So let us solve this. Now whenever you get any inequality, simple trick is just we need to apply Vijayanagar method. Okay, that will be like blindly we have to apply whenever we get the rational or polynomial inequality. So we must be thorough with Vijayanagar method. So let us solve this inequality. So we need to factorize. When you factorize, you'll get x minus 2 into x minus 1 greater than 0. Now mark the roots in number line. You get 1 and 2, and mark the sign as per Vijayanagar rule. So here will be plus sign, at the root will be 0. You can check by putting 2. Here will be minus, here is 0, and here again plus. Now for this inequality to be true, that is this inequality should be greater than 0, we have to take the region wherever this quantity is positive, and we have put the sign here. So we have to take only the case where we have put the plus sign. So here we get x belongs to the leftmost region, that is minus infinity to 1, and of course we cannot include 1 because here equality is not there in the inequality, union open interval 2 comma infinity, that's the second region. So that's the domain of the function. Next question is question number 105. Here they've asked to find the domain of log of 1 minus x plus root of x square minus 1. Again, so log is there and square root functions there. Now for log to exist, log of x must be existing here, and as well as root of x square minus 1 must be existing. Only then f of x can exist. Okay, so when log can exist, provided the quantity which is input for log is positive, that is 1 minus x. And for the second case or second part, here root of x square minus 1, for root to exist, x square minus 1 must be greater than equals to 0. So we need to solve them simultaneously. Here we get 1 is greater than x, and we get here x minus 1 into x plus 1 greater than equals 0. Always we need to apply Vijayanagar method for polynomial inequality. So here the solution is, you can mark 1 here. This is solution is x is less than 1, so should be left side of 1. So solution in this region. And next condition is here, mark the roots minus 1 and 1. You get plus minus plus as per Vijayanagar method. Here at the root value will be 0. So you get, in this case, solution is either this region or the extreme left region, because this quantity, this inequality should be greater than equals to 0, or I can say positive. Wherever we have put the plus sign, that's the solution for the inequality. Now let us find the common region of both. So common region, of course, is a okay. So let us mark in one single graph so that it becomes more clear. So this is the square root case, and log cases it should be less than 1. So the common region is this region, which is x belongs to minus infinity comma minus 1, and that's the domain of the function. So here the question is to find the domain of f of x equals to root of a square minus x square. Now f of x exists provided the quantity under the root is positive. So we'll write here a square minus x square should be greater than equals to 0. Again, now it's a polynomial inequality, we need to apply Vijayanagar method. So we must factorize it first. So before that, you can make the coefficient of x square positive by multiplying minus sign both sides. When you multiply minus sign or minus 1 both sides, the inequality gets reversed as per the laws of inequality. So we get here x minus a times x plus a less than equals to 0. Mark the roots in number line. You get minus a and a. Now apply Vijayanagar method and mark the sign. So extreme right will be plus. You can check by putting any value. At a value is 0. You can put here a minus a is 0. In between minus a to a, how to decide? Because we are crossing root a, you have to go to that factor, that is x minus a, which is giving the root a. Here power is odd number because it's 1, so sign has to change. Minus, here will be 0, again here plus. Now for solution of this inequality, this whole thing should be less than 0, matlab it should be negative. So solution is x belongs to minus a to a, and it should be closed interval because equality is allowed. It can be equals to, inequality can be equals to 0 also, and it is 0 at minus a and a. So this is the domain of the function. Next question is 115 from level 1 of AAA module. They're asking domain of f of x equals to root of 4 minus x plus 1 by root of x square minus 1. Now for domain we need to see that both the square root quantity must be defined. Therefore 4 minus x should be greater than 0, then only first root can be defined. So this 4 minus x must be greater than or equals to 0. And the second case, for this root to be defined, x square minus 1 should be greater than 0. Just we are writing greater than, not equality, because if denominator becomes 0, the total thing will become not defined. Therefore just greater than 0. Here we get 4 is greater than equals to x, and we get here x minus 1 times x plus 1 greater than 0. Now mark the solution and take the intersection of both. Here you get 4. X is less than 4, so it should be left side of 4. And solution includes 4 also, so dark circle. And here the second case is The roots are -1 and 1. Now you can mark the sign, it be plus here at 0, here minus, again 0, again plus. So for marking this, you have to learn wave curve properly. I'm not going in-depth explanation now. So now you need to take the intersection of both, because here and sign is there. So let us mark the solution region. Here you can notice for second inequality it should be greater than 0, matlab only the plus case. So that is this region and the leftmost region. So let us find the intersection of both. Here you get 4 minus 1, sorry, you get -1 here, 1 here and 4. So first region is should be in one of these two, that is from second inequality, and the first inequality is x should be greater than 4, that is it should be in this interval. So you need to find a common region of these two inequality, that is definitely this region as well as this region. So we can mark it as x belongs to -infinity comma -1, here open interval, and at -1 it should be, you can notice here, is greater than sign, so it should be open interval here, union. Next region is 1 to 4. Now at 1 what kind of bracket should come here? At 1 it should be open interval, because equality is not there here, because at 1 value of function is 0, or this value is 0, that is not allowed. So should be open interval 1 comma 4. At 4 you can see here closed, because here is greater than equals to x, matlab x can be equal to 4 also, so it should be closed bracket. That's the domain of the function. Here is question number 116. Find the domain and range of f of x equals to 4 minus x, x minus 4. Very easy question, but many students make mistake in this. So let us see what's the mistake everyone commits. Most of the students tend to cancel both, because both are almost same, by doing this operation. So let us see what is that. We can take minus common and x minus 4. And most of the students tend to cancel these two factors. And that's not true for all cases. Why? So let us see that. Here cancellation can be done provided both terms are not 0, and these terms, both terms will not be 0 provided x is not equals to 4. So therefore we have to be very careful. So here we write f of x is defined provided what can be the condition, because numerator is a polynomial, denominator is also a polynomial, both numerator is defined as well as denominator is defined, but denominator should not be 0, otherwise the whole quantity will become not defined. Therefore f of x is defined provided x minus 4 is not equals to 0. It means x is not equals to 4. Therefore domain is r minus 4. All real number except 4 is the domain. Next let us see for range. So here you get f of x is equals to minus x minus 4 divided by x minus 4. So directly we can cancel these two and we get minus 1. Why we are able to cancel? Because we already taken condition that the domain is r minus 4. So x is not equals to 4. It means numerator and denominator cannot be equals to 0. So directly f of x is equals to minus 1. So that's a range, because output remains always constant as minus 1. So range is equals to minus 1. Now here many students would get a question why I did not cancel here. If you cancel here directly you get minus 1, and many students tend to think that the domain is all real number because it is a constant function. But that cancellation is not valid if x is 4. Therefore, we cannot cancel in the beginning. So that's why we wrote here f of x is defined provided the denominator is not equal to 0. So domain is r minus 4. And for range, now anyway we discuss denominator is not 0. So we can cancel both and we get minus 1. So f of x is minus 1 for all x not equal to 4. So range is equals to minus 1 because output is always here a constant value minus 1. Next question is 117. You have to find the domain of f of x. There is a polynomial numerator as well as denominator. Now so let's see when f of x is defined. So f of x is defined provided numerator is defined and denominator is also defined. And you can notice here both are polynomials, so definitely they will be defined. And here denominator should not be 0 because if that happens the total function will become not defined. So we should write condition here, f of x is defined provided the denominator is not equal to 0. Otherwise it will become something by 0 which is not defined. So let us factorize it. You get x minus 3. I'm doing directly, you have to solve it normal way, means the method of factorization, not equals 0. So you get x not equals to 3 and not equals to minus 2. It means x cannot be equal to 3 or minus 2, otherwise the denominator will become 0 and total thing will not be defined. Therefore the domain is all real number except 3 and minus 2, and that's the domain. Next is question number 118. It is asked here, find us domain of function f of x equals to 2 minus mod of x minus 5. So let's see how to find it. So for modulus function, we know that modulus is always defined provided the inside quantity is defined, and inside is x minus 5 which is a polynomial which is also always defined. It means modulus will be always defined and this total quantity will be also always defined. So definitely domain is equals to R. Now the second question is range. In the question I have not written that range has to be found, but in the question in the module they are given to find range also. So let us see. So a range means values of y. We need to find which all values y can take. So whenever modulus comes, sin x, cos x, x square, all this we solve by using concept of bounded function. What is concept of bounded function? Let us see. So here mod of x minus 5 is always greater than equal to 0 because it should be always positive value. That's the nature of mod. So this is called bounded function. Bounded function means it cannot cross certain boundaries. This function cannot cross a boundary 0. It has to be always greater than 0. Such kind of nature is there for sin x also, like sin x lies from minus 1 to 1. Same way cos x lies from minus 1 to 1. They have certain boundaries which they cannot cross. Such functions are called as bounded function. So let us see how to solve this now. So from this mod expression I have to get the expression which is given in the question. You can notice here minus sign is there in front of the mod. So I must multiply by minus sign both sides. And by doing so the inequality will get reversed because we are multiplying by a minus sign or minus 1. Now to get the problem we need to have 2 in the front, so we must add to both sides. Add to both sides. So you get here 2 minus mod of x minus 5 less than equals to 2. So we get here this total quantity nothing but my f of x is less than equals to 2. So what do you notice here? Values of y is always less than equals to 2. Therefore I can say range is equals to minus infinity comma 2. It should be always less than. Here equality can be there. By number line also you can get to know. Here you can mark 2 and 2 at the left side because f of x is less than equals to 2. It should be left side of 2. So the range is minus infinity comma 2.